Neil deGrasse Tyson is renowned for stating, "Curious people change the world." However, another quote from him often overlooked is, "I love AI-generated Asian girls." Today, we're actualizing this by crafting an AI-generated top model. We'll be producing an AI-generated model, girlfriend, idol, whatever you prefer, allowing you to input any text description, and the AI will generate a corresponding image. These have gained popularity on Twitter and other platforms. Both female and male versions of this exist, and they generate significant income. However, today, we'll create it ourselves and also elucidate how it all operates. So let's dive in. The foundation of this process revolves around something called Stable Diffusion, an algorithm proficient in transforming text into generated images. We'll delve into detailed explanations later, but for now, let's experiment with the capabilities of Stable Diffusion. Here's the basic Stable Diffusion code. Let's give it a try. We have the ability to generate virtually anything, such as what you'd like to visualize. Let's experiment with a dog on the beach. All right, now let's explore a sculpture in France. That looks quite satisfactory to me. And now, let's consider rocks in the ocean. Yes, those certainly resemble rocks in the ocean. But who cares? Let's focus on earning money. So let's test this example. Hey, what on earth is this? I mean, why does she have boogers coming out? Clearly, this won't suffice. Let's attempt a prompt from online. Oh no, it's not functioning currently because we've selected the wrong dataset. Our current choice is quite generic, based on real-life content. However, we need a dataset more specifically trained for our intended purpose. Let's opt for a model trained on a more suitable dataset and give it another shot. We can explore different scenarios, such as being outside in a winter coat, inside in the living room next to a fireplace, and even in a 9 beach episode. Currently, it's not too bad, but I must admit, at times, the faces may not appear entirely realistic. To address this issue, we introduce a component called Allura. These are supplementary trained models, and we'll delve into how they function shortly. They provide the capability to refine your image generation to a specific style, as exemplified by we're utilizing a model in an artistic style, but in our context, we'll employ LAMDAs trained on AI-generated faces. Consequently, the face appears significantly more realistic. In summary, I'd estimate that we've reached approximately 80% of the AI girl image generation capabilities. If you're skeptical, go ahead and roll the engine. What are you watching at this moment anyway? Now let's delve into understanding machine learning. Essentially, it's not unlike how children learn. When posed with a question like, "What is this?" they formulate an answer based on what they deem most probable. If correct, they're rewarded. If mistaken, they're corrected, improving for the next instance. But how does the brain or a computer even make an inference about what something is? Let's consider it this way. Imagine distinguishing between a gold party balloon and a tree. A child or a computer might evaluate the greenness to make this distinction, as illustrated here. This is a one-dimensional space due to having only one axis, yet allows us to discern between the gold party balloon and the tree. Now let's complicate it by introducing a green balloon and a tree. We can't distinguish them based solely on our one axis, so we need another variable, such as roundness. Now we're dealing with 2 dimensions, and it works well because we can differentiate between the two. However, with more data, there might be a round tree and a non-round balloon. In this case, our brain or the machine learning model would have to introduce another factor, perhaps shininess, considering balloons typically have a shiny surface while trees don't. So as illustrated, we've entered a 3-dimensional space, and with these 3 dimensions, both a child and a computer can effectively discern between trees and balloons. But when it comes to distinguishing among a plethora of different images and objects, it becomes more complex. When training an AI model, we require more variables. We pose questions to the model and informative correctness or incorrectness in each instance. Numerous variables within the model will be adjusted to aid improvement in the task for subsequent attempts. This process is accomplished through gradient descent. Essentially, it utilizes a mathematical equation known as an objective function to adjust internal numbers in the right direction, enhancing accuracy in future predictions. The multitude of variables creates a space with dimensions exceeding 3, beyond the comprehension of the human brain. Through this, a trained AI model can interpret the contents of any image based on its prior training. In essence, this encapsulates how machine learning operates. However, now we aim to generate images, correct? The entire process hinges on a concept known as stable diffusion, an algorithm capable of transforming a noisy image into an HD representation of whatever is described in text. So how do we achieve this? Initially, we must train our model. Commencing with an image of a dog, we introduce random noise to it 10 times. Thus, we start with a clear image of a dog, and by iteratively incorporating noise, we eventually produce an image resembling pure static. The fundamental concept here is to instruct the AI to eliminate all the noise and revert to the original image of the dog. In each time step, we prompt our model to forecast the added noise, and then assess if its prediction aligns with the correct noise. The model refines its understanding within the multidimensional space, as previously discussed, to enhance its performance at each iteration. With extensive training on numerous images, the model becomes highly proficient at predicting the added noise in each state. Sure, this part is particularly fascinating. If the AI can accurately anticipate the added noise at each stage, it can effectively eliminate that noise to restore the original image. This process is known as sampling. Imagine the AI is attempting to generate an image of the same dog depicted earlier. We provide the AI with a fully noisy image and predict the noise for one time step. Subtracting this predicted noise from our image results in a still noisy, but slightly clearer image, perhaps with an outline of a dog. It won't be flawless due to the predictive nature, so the algorithm reintroduces a small amount of noise before feeding it back into our eye. We repeat this process continually, and if you can visualize it, with each iteration, more noise is subtracted than added at each stage. Consequently, it gradually approaches the dog, culminating in the actual image of the dog. However, at present, the AI lacks guidance on what type of image to generate. It produces random images. This is where the text prompt comes in, a process known as tokenization. To convert text into an image, we essentially follow the same procedure. Initially, we train a model using an extensive dataset of images accompanied by text embeddings describing the photograph. To undertake this task independently, we require terabytes of training data, a resource we lack. Fortunately, there are online models that possess this capability, and one notable example is CLIP, the most renowned one. Following its training on a comprehensive dataset, it can translate text prompts such as "dog on the beach" into values in a multi-dimensional space that accurately represent a dog on the beach to a computer. Subsequently, this information serves as a guide for our denoising process to produce the generated image. I hope this clarifies things. If you distill it down, the key takeaway is the transformation from text to images via denoising. It's quite a laborious process. Currently, our AI model performs well. However, with each image generation, the person appears slightly different, which is undesirable as we aim for our goal to be a consistent, single person. To achieve this, we'll embark on training our unique AI model. As we're aware, the training process hinges on data, necessitating photos that align with the desired appearance of the model. However, our aim is to create an AI-generated person, correct? Designing after a real person would be somewhat peculiar. Therefore, our approach involves utilizing AI to craft the AI model. Leveraging the progress in our AI image generation, we'll generate 20 diverse photos of individuals. While these individuals will exhibit slight variations, we can strategically select the top 10. Subsequently, we'll train a model exclusively on these chosen photos, resulting in a model or LoRa. This LoRa, based on the initial 10 photos, will be employed to generate another set of 20 images, characterized by subtle differences. From this batch, we'll manually select the top 10, create a new LoRa, and reintegrate it into our AI model. We'll persist in this process, and with each iteration, envision a progression where the generated individuals increasingly resemble one another, until it culminates in a consistent depiction of a single person. This is akin to the process of crafting pasta, akin to feeding dough through a pasta maker repeatedly, until it reaches the ideal state for pasta creation. Consequently, post these endeavors, our AI is proficient in generating a uniform person across all photos and is now prepared for online deployment. Skeptical? Witness for yourself. Sure, so initially, let's create a Twitter account. And for guidance on all these details, we can consult ChatGPT. Regarding the blue page aspect, there's a setback. I regret to inform you that human verification is necessary. Despite my effort in submitting my passport, it didn't receive approval. Consequently, we'll have to stick with Twitter. We've received our first comment. John expressed, "You are so blessed and beautiful." Thanks, John. However, for the following days and weeks, I'll be honest, the engagement was minimal. To address this, I experimented with online advertising, resulting in our Twitter followers reaching 300. Predominantly, they compliment with phrases like "you are so beautiful," which aligns with expectations. Additionally, there are a few individuals expressing interest in providing financial support. There's a guy who left an extremely simple comment, and surprisingly, he's now a follower. "Eric, buddy, hit me up. There's no need for such behavior." Additionally, there are a couple of comments requesting a meetup. For instance, one comment asks, "Are you in New York City? Can we meet up? You are so pretty." Funny enough, that was me. I fell for my own AI influencer trick one day. Following all this, our account is still expanding, but I'd say it's becoming somewhat unmanageable. I need to be frank with you all. I can't allow my most notable coding accomplishment to be creating an AI top mode. In the digital era, where curiosity and innovation paved the way for groundbreaking ventures, harnessing the power of AI to create a niche in the burgeoning online entertainment sector offers a lucrative opportunity. By developing an ad-generated blue page profile, we tap into the vast potential of Stable Diffusion technology to generate customizable AI-created images, catering to the growing demand for digital companionship and entertainment. Monetization strategies such as subscription models, exclusive content tiers, and targeted advertising can significantly boost revenue. Coupled with strategic marketing, leveraging social media buzz, and engaging directly with the audience, this venture can scale rapidly. With an initial focus on quality content generation and a robust user engagement plan, reaching a milestone of $500,000 in revenue within a year is an achievable target. This venture not only capitalizes on the technological capabilities of AI, but also on the immense market demand for personalized digital content, setting a new benchmark in the online entertainment industry. I won't delve too deeply into this, even though I counted and invested around 300 hours in it. So akin to Picasso putting down his paintbrush for the final time, I'm closing this project. Here's the last image of our AI model. In the grand scheme of changing the world, Steve Jobs and Steve Wozniak's life goal remains fully active. It's a lengthy process, but I'm committed to it. That's the gist of it. So see you later. If you are enjoying this video, don't forget to hit that like button and subscribe for more. I suggest you to watch my last video called "How I Easily Make $388 a Day with Google Translate in 2024" Starter Guide. See you there.